Thank you very much, Ahmed. The title of today's session is Open Source versus Proprietary Software Running on Disaggregated Hardware, but it also involves the current status and future directions of open networking, a term coined by one of our panelists, Arpit Joshipura, or whatever happened to SDN, and has it been replaced by proprietary software? In 2011 and 2012, software-defined networking was the hottest game in town. It spread from networking to all of IT. There was software-defined storage, software-defined data centers. And since then, the interest seems to have faded a bit. However, we're going to explore how it has evolved. I want to thank all of you for joining. Before we dive into the presentations and panel discussion, I'd like to turn the floor over to Ashutosh Dutta, who's going to tell us about IEEE future networks.
Thank you, Alan. I appreciate you giving me an opportunity. I'll spend about 5 minutes just to give you an idea how IEEE Future Networks is also helping the ecosystem in terms of using the open computing, open source. To begin with, this is me, Ashutosh Dutta. I chair the IEEE Future Networks technical community. I work with Johns Hopkins University Applied Physics Lab in Laurel. So very briefly, just to see where IEEE Future Networks was born, about 6 years back, and it was incubated within Future Direction. This year, it became a full-fledged technical community. So Future Networks technical community, so it graduated from Future Direction. And now it is, there are 9 societies, ComSoc being the prime society who is managing this. There are other 8 societies who are part of it, our financial sponsor. Among other things, this is like a mini society where we have publications, standardization, conferences, Future Networks World Forum, Connecting the Unconnected, different podcasts, webinar, many of you must have participated. And at the same time, we're also building an open source testbed. I'll briefly talk about that. And research and education side, we are actually building a roadmap, a 3-year, 5-year, 10-year from now, how things are going to look like. This is our website. If you want to get more information about what Future Networks IEEE within IEEE doing, how to get involved, different aspects of it, publication, standardization, industry engagement, education, etc. Right? So I won't dwell over that. Most importantly, we have about 200 volunteers from around the world, different regions. We are working on INGR, which is International Network Generation Roadmap, 3-year, 5-year, 10-year from now, how things are going to look like. So this is helping contribute to the research aspects. We also collaborate with other OUs within the industry. And the last edition, 2nd edition was published. Right now it is in IEEE Explore. These are different working groups. If you want to get an idea, get involved as an IEEE or ComSoc member or any society member, you should have free access to these. As you can see, we cover all aspects starting from application, AI, ML, digital divide, millimeter wave, hardware, optics, satellite, deployment, edge service, energy efficiency, massive MIMO, systems optimization, and finally, the testbed part. We are building a testbed right now, but we have a survey of all the testbeds which are out there in the world that you can take advantage of. I'm sure you're going to hear more from the panelists today. So this is 2-3 slides on this. This one was sponsored by New Initiative Committee. IEEE never had an open source testbed. And I was talking to Arpit the other day about the value of it. We're going to make it available to the operators, application service providers, academics, They can use this as a platform, use open source to build different proof of concept, or any specific use cases they can do testing, etc. So this is still in the process of getting built. Tech Mahindra is helping us integrate this whole thing. We just completed the first phase. It should be available for use within next 2-3 months. If you're coming,
is there any other open source networking software that IEEE Future Networks is pursuing besides 5G, 6G?
Right now, this is our focus in terms of the actual implementation, right? There is IEEE Standards Association. There is an open source within that's being pursued, but they are not really contributing to the open source in that way, right? So that is another aspect of open source that people should be interested in. Future Networks right now is contributing to this testbed, plus all the roadmap, INGR roadmap that I spoke about. So, next minute or two, the operators, vendors, application developers, academia, they can all make use of this. We have a platform overview. This is showing, we also have a collaboration Open RAN consortium as well, Open RAN Alliance. We are building a 5G core from open source. All the other modules are also open source based right now. We have planned to make it more like a federated testbed. There are other testbeds out there. If you go to the website and look for a white paper, it lists all the different testbeds out there. So our plan is to connect this in phase-wise approach and connect to other parts of the world, other testbeds. I think that's kind of my last slide. So I just want to give you an idea how you can get involved in future networks, not only in the roadmap, but in other ways like standardization, education, conferences, and last but not the least, this testbed project that we're doing right now. Alan, the IEEE Standards Association has a separate open source project. They're not building the testbed, but we are just kind of complementing what we're doing here on future networks.
Okay, thank you very much, Ashutosh. I have a question from my good friend, Ken. Does the 5G testbed project work with the Broadband Forum and their University of New Hampshire Interoperability Lab?
Actually, that's a very good question. As I think initially we are just building it phase-wise. Our plan is to really have interoperability with other testbeds out there, not only within the United States, but in Europe and elsewhere. Austin big 5G event. If any of you are coming there, we have a panel about this specific one, and where AT&T, VMware, China Mobile, Samsung, they're already members of this specific testbed. And Anwar Al-Dawami, my co-chair of testbed, he will be also there. It's on May 16 between 2 p.m. and 4 p.m. Central Standard Time.
Okay, thank you very much, Ashutosh.
Mm-hmm.
Okay,
let's stop sharing. Anything else? Or?
No, that's it. Let's move on. We're going to be pressed for time because we have many questions for the panel during the discussion. Now, for audience members, please put any questions or issues you have, requests for clarification or elaboration in the chat, and we'll ask them during the open floor Q&A, which will follow the panel discussion. So now we're going to start the program in earnest. We are so fortunate to have 3 expert panelists on this subject matter. The first of which is Roy Chua, who I would say is the dean of software-defined networking and open networking. He was actually involved before the first SDN summit put on by the Open Network Foundation in 2011, which I attended and was very impressed with. Roy has been the co-founder of SDX Central and the founder and chief analyst at AvidThink. I can't tell you how fortunate we are to have him giving us an background overview, and current status, future directions of this topic. The floor is yours, Roy.
Thank you, Alan. And that was a very kind introduction. I probably was the first external grad student, not the dean of open source networking more than anything else. But let me get started. It is an extensive and expansive topic. And so I would ask that I would say, I'm not going to be able to do it justice in 20 minutes, but I'm going to try to keep it to 20 minutes because I don't think there's any sense in spending hours here on that one topic. There's a lot more interesting questions I know that Alan has in store for us, so we want to get to those. But maybe just to get all of us on the same page or roughly the same page, I thought I'd start with, sort of taking a look back at open source and networking. And then as Alan says, we'll talk about where we are today and what's going on. So couple of wise thoughts. Software is eating the world, right? We talk about, software eating the world, and open source is eating software, is open source eating the world. And, open source is definitely one of the key drivers in software in technology today. I think there's no doubt about that. A lot of key elements that we use in our daily lives are based on open source. And what does open source like to eat? Well, open source likes to eat proprietary hardware, proprietary software, hopefully not people. All right. So anyhow, so open source and networking is everywhere. And we've heard the term let 100 flowers bloom or let 1,000 flowers bloom, depending on whether you have it in the original Mandarin or the English version of that. It was expanded. But fundamentally, when we look at open source or open in networking, it spans probably a lot more than maybe we think, or that we have visibility into at any point in time. It could be sort of hardware related, so it could be a network operating system. It could be, in some sense, sort of a language to program hardware devices and software devices as well. It could be orchestration all the way on the other side, right? It could be security. It could be automation. It could be application infrastructure, or the infrastructure, networking infrastructure itself, or even analytics. And so there is a wide span, I think, when we look at open source and networking. It's not just maybe OpenFlow, the origins of when SDN became popular, or P4 or languages like that, but fundamentally, open source is everywhere. And if you look at the vast majority of networking equipment today, a lot of those networking OSs that power that equipment are either based on some variant of Linux or stripped down Linux, or some BSD version, right? From all the way back to the 386 BSD and then NetBSD, FreeBSD, all the very open BSD and so on. So, so fundamentally, it's everywhere. And so what we're going to talk about here, and Alan points out, is when it became sort of hot, became this big thing. And Alan was right, 2011, 2012, 2013, Open Networking Summit, and then all the other shows that came after that expanded. It was the thing, right? We talked about networking being cool again. I remember being on stage and saying, well, I guess networking is cool again, right? And maybe it didn't hit maybe
some pundits called it a new epoch.
That's right.
Revolution.
A revolution, exactly. We did, and we felt that there was going to be change. And I think sort of the kind of long story short, and what you hear from me at the end is that it did change, but maybe not in the way we expected, maybe not as big a bang as we expected, but multiple little bangs all over the place, and we'll talk about that. But pre-SDN, pre-OpenFlow back in 2011, there was already open source networking, right? There was TCP/IP stacks. I drop an I, sorry about that. The Swansea University of Swansea TCP/IP stack, SNOT, right? ZOP, the routing stack, Quagga, that was open source, and that was networking. But of course, when OpenFlow came in, there was a lot of hype around, OpenFlow, Open Networking Foundation was established, right? OpenFlow 1.0, 1.1, all the standards came, and then the flurry of controllers, right? We thought that the controller was the platform. We're going to write applications on top of the controllers. There was going to be a controller marketplace, right? There was Knox, POX, all these various controllers, commercial versions. Cisco had a controller. HPE at some point had 3 controllers. NEC started shipping switches with OpenFlow support. It was a big ecosystem. We had competitions and hackathons around controllers. Then we realized later on that maybe controllers were not easily monetizable, and then became sort of maturation, right, of the space. And but along with that, virtual switches, virtualization fabrics, right, OVS, right, Open vSwitch, and then subsequently OVN, all those were hot, and they exist today. By the way, all these technologies are still around. We're still using them. WAN adoption on the WAN side, we saw WAN taking on SDN when we heard that Google's B4 WAN network was SDN controlled. Everyone needed a SDN WAN at that point in time, right? Not SD-WAN, SDN WAN, right? And then then we had controller consolidation. We realized we couldn't support so many controllers, and Open Daylight and ONOS became sort of two more prominent ones out there. But obviously, that was not the end of controllers. We still had Fawcett and many other controllers that still survive sort of the controller wars. There wasn't really wars, sort of a war of attrition. And then we realized that OpenFlow wasn't quite going to do it. Maybe we were a little naive. So along came P4, which still exists. P4, there was just a P4 summit last week, right here in Santa Clara. So it continues. It's still there. And then Network OS, we thought maybe we want to replace the Network OS on those switches and routers. And so Sonic's still a thing. In fact, it's still a hot thing. With actually more and more commercial operators taking that on as well and making it available as an option. And then the SD-WAN side of things came along, taking open source into a lot of commercial SD-WAN solutions. In fact, a lot of commercial SD-WAN solutions have a lot of open source embedded in them. But there are unfortunately very few open source SD-WAN. I know of only one at this point in time that's out there in the market. And automation. So we went up the stack. Automation, OpenConfig came along. It's still not what it really ought to be, despite the support of many carriers and people like Google and even Cisco and Juniper, but it continues. And so it's a long journey. It continues. It's still there. So open source and networking continues to be there. Maybe we didn't quite achieve that controller ecosystem, controller as the new operating system for networking with an app store and marketplace and all of us buying apps on our phones for our network switches at home. Not that anyone has a network switch at home. You probably do, but you don't care about it. But it exists, it continues, it persists, right? So I think that's one side of it. The other side of it was the NFV journey, which went side by side. Those of you in the early days of SDN will recall SDN NFV was normally stated in the same breath, right? SDN NFV, right? It's like one word, except it wasn't. And we wanted to virtualize network operations, network applications, routing, firewalls, and so on. And so we built the foundations, the reference architectures for NFV. We tried to accelerate those network workloads, trying to rip them apart from proprietary hardware, trying to get the performance out of it. So we had PCI pass-through, SRIOV, DPTK, all these things came along. And FIDO, VPP, many of these projects that actually the Linux Foundation continues to host and move forward as well. But we realized that was not an easy thing. Ripping stuff out of proprietary hardware in sort of standards-based architecture or even open architecture was a tricky thing. We went through the VNF, or virtual network functions, onboarding challenges, the orchestration games, as you remember, different orchestrators that still exist and still run today. And then we went, even before we figured out the virtual machine game and how to optimize those, containers came along, and we suddenly jumped to containers because containers and Kubernetes was a new hot thing. So we jumped to CNF, Cloud Native Network Functions, which is sort of where we're at today. And then along came 5G, explosion of SD-WAN and Edge and security, and all these other open source projects came along. So ePPF, Nephew, right? And then on the 5G side, we have Magma, which is struggling a little bit, Free 5GC, other 5G cores. So all these are all open source projects, and they power networking from a networking application or networking service standpoint. And that, again, continues. It never ends. The ecosystem in the open source and networking is pretty big, right? You have the different foundations here, of which you see listed. I'm not going to go through every single one of them. You're welcome to reach out to them. I'll point out one at the bottom left, Linux Foundation, Networking, and Edge, which we have Arpit here today to represent that. But certainly, they also collaborate with all the other open source and networking foundations. Hopefully, I haven't missed one. I'm sure they will remind me if I miss one here. So let me just maybe take a pause and say, that's all interesting, and open source networking is pretty cool. But it has to be in service of something. And so in the next couple of slides, I'll talk about sort of where we are, what we're seeing as analysts in working with clients and working with enterprises and carriers.
Before you do that, let me just interrupt
Yes,
for the benefit of the audience and define things a little bit that you had mentioned.
Yes.
A fundamental concept of classical SDN was hierarchical routing, and this would be done by an SDN controller. The traditional routers became packet forwarding engines, and they no longer computed routes hop by hop, but rather that was done through this SDN controller. Is that correct, Roy?
Yes, with a slight, I would say, modification, which is when SDN came along, and you're absolutely right. I should have been clearer around what.
I just want to embellish some of the things you said,
Yes.
which the audience may not be familiar with because they weren't around
Absolutely.
in 2011, 2012, like
Exactly.
we were.
I've been doing this for 10 plus years, so it's sort of in there. And
Right.
that's a good point. So what SDN, when SDN came along, what it pushed was the separation of the control plane from the data plane, which is what you're pointing to. That the control logic was run usually centrally somewhere else.
With OpenFlow, the API between them.
That's correct. Originally, it was OpenFlow, but could have been any other protocol as well. There's multiple ways of doing it. But yes, originally, as proposed back when OpenFlow was hot in 2011, 2012 timeframe, it was separation of control plane and data plane, and that the OpenFlow was the protocol to talk to the switches, and you would basically program the logic into the switches and centralize that logic. So that was the original thought around SDN. Absolutely, yes. Separation
Now, with
of
NFV, NFV was developed by Etsy,
yes,
but it was premises-based virtual appliances, not cloud-based.
Originally, that's correct. Originally, it was
now it is. Now I think it has evolved.
It has
to something that's in the cloud, maybe with different constructs like containers or Kubernetes or whatever.
So it has evolved to cloud native architecture. It doesn't mandate in NFV even with CNFs, cloud native network functions. It doesn't mandate that all controls in the cloud. What it does recommend, what the architecture does promote is cloud native network architectures. And what that means is that you usually have microservices, collaborating services, more component-based architecture, leveraging cloud type principles, cloud type capabilities like continuous CI/CD, right? Continuous integration, continuous deployment. So those concepts are in there. And likewise, what you see in those CNFs are more collaboration, more use of queuing capabilities, more use of sort of microservice architecture, more use of key value stores and things that more modern cloud type applications tend to use. So those are the principles of it. Whether your actual control plane needs to be in the public cloud or a private cloud somewhere, that's left open, right? It's just an architecture approach. It doesn't.
Okay, thanks for that elaboration. Please continue.
Yep, excellent. Well, thank you. And ask questions because, and you're right, I've been in this and doing this for too long. So it sort of, I forget.
I'm only going to break in just to provide clarification to audience members who are fairly new to this field.
Yeah, and feel free to do that. And likewise, the audience, if you have questions. All right, so let's take a look at what the market's asking for, and and what open source networking, if it wants to continue improving, if it wants to continue traction, it needs to address these things. And so what we're seeing in enterprises is the ongoing digital transformation, digitizing everything, right? Any process that's there that can be digitized can go from analog to digital, so they can manage it in, with cloud technologies or software. That's all happening. Factories, logistics companies everywhere. Likewise, with the pandemic, even pre-pandemic, there was already sort of remote access trying to provide productivity for workers anywhere, right? Regardless whether you're working from home or working from anywhere. To provide you secure access, so zero trust access. I wouldn't go into details on the security framework there, but and likewise with mobility, right? What are you going to get from 5G and 4G, right? So that's ongoing. The other thing that I'm seeing enterprises deal with is managing what they call the threat surface. In other words, what are the areas of attack from the outside, right? Cyber attackers coming in. How what are the areas that they can attack, for the enterprises? And then on the next line there, you see cloud transformation. It's still a thing. People are looking at how to leverage clouds. many large organizations tend to use multiple clouds because for various reasons, different departments prefer different clouds have different services that may be more appropriate for their business needs. Collaboration continues. This X versus metaverse thing, I would say, yeah, it's kind of happening, but the reality is it starts with, augmented reality first, someone on the factory floor, maybe trying to troubleshoot something, improve collaboration. When VR can be used to simulate things or for training, certainly that's ongoing, right? The metaverse may still yet to come, but it takes some time, but there are real world business problems that can be solved with AR, VR today, and that's going to continue. Likewise, we are also seeing on the networking front, around the 5G hype, the 5G actually in release 16, 17 onwards does support private networks. In fact, it already did, but it's going to provide even more support for private networks, which is basically not public, your big macro 5G networks, but in fact, your own little personal private 5G standards powered network. And that usually runs in concurrence with your Wi-Fi or your Ethernet, wired Ethernet networks. And it brings you more consistency, reliability, and potentially more scale down the line as well. So that's happening. And then fundamentally what enterprises want to do when we talk to them is we want to get new services out to be competitive. Fast time to market is what we care about, among other things. And on the consumer side, it's going to go through it. I think we all live this. I want faster, cheaper bandwidth on the networking side. I want IoT, but hey, can you make it transparent and safe? I keep hearing about my video cameras getting compromised, right? I want better experience. I want lower latency. I want more precise location for new applications. I want connectivity anytime, anywhere. Don't tell me about 5G. Give me a signal, right? I don't care if it's 5G, 4G, just give me a signal. And now when you go to stadiums, people want new experiences. And they want internet everywhere, right? Digital everything. That's what networking is supposed to bring us as consumers, ideally. On the carrier side, right? So we talk about enterprise, we talk about the consumers. What are carriers concerned about? The carriers are concerned about application experience because that's what the consumers and the businesses tell them. They want to give you some kind of quality of service end to end with visibility and troubleshooting, and they need to do that in context of a changing first mile, trying to build all that first mile out. And hyperscalers dominate a lot. The large data centers dominate a lot. Subsea cable expansion continues, right? People are asking for direct cloud connections. I got to give you that as carriers, right? Somehow, because the businesses are asking for that. Consumers are not necessarily asking for that, but certainly the businesses are. The new middle mile, which bridges the first mile and the last mile. And on the last mile, I'm trying to do build outs, right? We're trying to get the underconnected, unconnected, connected, and you bring more of that in there, regardless of how you do it. Fixed wireless access or fiber or low Earth orbit satellites, right? And provide protection with SD-WAN and SASE. As I do the last mile connection, I've got to build up the middle mile as well. How do I expand my metro networks going from 400 gigs to 800 gigs to 1.6 terabits? How do I deal with this multiple edge and edge computing and all that? So from a carrier perspective, these are all the networking things I have to deal with, right? And obviously, when we talk about open source networking, for it to be relevant, it's got to help me with some of these or all of these. And so, there's different viewpoints around open source and networking, right? Given all those concerns that enterprises have, consumers have, and the carriers have, right? What do we see when we talk to some of these people? And again, our viewpoint in talking to them, right? So this is representative of what I think, right? Cloud providers, they love it, they use it, leverage it. Sometimes they give back, sometimes they don't. And it's not just open source networking, it's true of other kinds of open source as well, right? Database technology, other technologies. Service providers, they like open source networking. Why? Because number one, they get something for free. Number two, they use it as a leverage point or as a negotiating bargaining chip with the vendors. It's like a discount coupon, right? Hey, I got an open source alternative. Cisco, Juniper, Huawei, give it to me cheaper, right? Because, hey, I have an open source alternative, right? Potentially. And they're trying to figure out how to give back, right? Some of them don't know how to, some of them know how to, right? But generally speaking, they're trying to figure out how to collaborate and work on it. On the enterprise side, they know how to eat open source on the computing side usually, but open source networking, not so clear. And they are like, give back what? How do I collaborate? That little confused, right? Enterprises usually as we talk to them. On the vendor side, it's a love-hate relationship. Certainly, some of them take advantage of it. Sometimes they give back, sometimes they don't, right? Because again, it's competition potentially for some of these networking vendors, right? So different viewpoints out there in the industry.
That's a terrific slide, Roy, and we're going to come back to it
Sure.
during the panel discussion.
Yeah, absolutely. And again, it's my viewpoint based on conversations I have with all the different parties, right, on an ongoing basis the last 10 years. So what are the challenges that we see with open source networking? It's those 100 flowers or 1,000 flowers. How do you keep track of all those projects, right? There's a lot of projects out there still. Some one-hit wonders out there, and obviously, Darwinism plays a role. Maybe we have to assist with the pruning, right, just to get things going a little faster, right? And standards are important, and it's less of a debate nowadays. I mean, early on, it's like standards important. I think now we realize that it's basically a mix of standards and source code, right? So I think it's important to have both code contributions and also standards, ad hoc or otherwise. I think that balance, we're learning. There's still limited commercial success, right? We don't have the Red Hat Canonicals who also happen to sometimes contribute to open source networking, but have been more successful with operating systems and applications and middleware with open source than we all have with networking. Part of it is I think networking is a hard problem. It's a specialized problem. And if you look at a rack today, right, you have maybe one switch with 48 ports, and then you have 48 servers behind that. And so if you look at the footprint of open source networking, in some cases, is much smaller than what's on the servers, right? TCP/IP stack aside, right? So I think there are some market dynamics that make it a lot harder to succeed with open source networking commercially, right? And we have a lot of developers out there in open source organizations, right? What are the role of all these different organizations? Are they marketing vehicles, or are they involved in building community? And I think it depends on which one you talk to, right? And there are independents out there, right? How do we give them voice? And fundamentally, a lot of times what we run into is this absorptive capacity and contribution capability. And what that basically means is that a lot of organizations, they can't consume open source easily. They can't, much less contribute. They don't have the capabilities. They don't know how to. They may not have the talent to. They certainly don't understand how to do it from a business standpoint. And sometimes they worry about security and legal worries. And I know that the open source organizations continue to fight that and push that and try to educate, right, as best as they can. And that continues to be the case. And that's not a open source and networking problem per se. It's an open source problem, right, in general. So where do we go from here? Last two slides, I promised. Or maybe last 3 slides. But so fundamentally, I think we see an expansion of scope. I think we'll see open source stretch in more places. We're seeing more open source around like edge orchestration with Nephio, NEPHIO, and MCO, and Arpit may talk about those. Those are Linux Foundation networking projects, for instance. We're going to see growth of the vertical stack up and down. So it's going to stretch horizontal, it's going to stretch vertically. Open source and open in general, I use that more liberally, down to chip standards and chiplet standards that people like OCP are working on, for instance. And then cross-org efforts, right? We need to drive substantive cross-pollination and integration between the open source organizations, and some of them play integrative roles, like TIP, for instance, will put together the standards and provide blueprints, and so do the other organizations. So I think we see a lot of other parties coming in, and certainly, networking vendors in open source and networking, certainly, they're competitors and so a little tricky. But I think the neutral parties, the foundation technologies, so the chip manufacturers, the silicon manufacturers, and the consumers, the cloud service providers and the communication service providers can play a role in driving cross-org efforts. And I think we'll see more of that. And I think the ecosystem will continue to expand before it shrinks. I'm not seeing the Kubernetes moment yet. Those of you familiar with what happened on the orchestration side for containers, there were multiple choices back then. It wasn't just Kubernetes. Now we only know about Kubernetes. We don't talk much about Docker Swarm, or other of the alternatives back when, but there were more than one alternative. And all of a sudden, everyone decided to just jump and say, you know what, we'll just go Kubernetes. And that collapsed very quickly. Now, part of that was Kubernetes came from Google. There was momentum behind it. But because of the collapse, everyone jumped on one ship and it was a little faster, and everyone sort of rode in mostly the same direction.
Hasn't that been the big problem, though? That the lifetime of these new implementation initiatives for cloud natives keeps changing.
Yes, yeah, it is. But at the same time, I would say that there's been an advantage for the cloud native folks that we don't have big fights over Kubernetes, right? I mean, there are changes inside Kubernetes itself, but because all the other alternatives collapse in Apache Mesos, right? So Mesosphere, Docker Swarm, right? Rancher, all these guys decided, you know what, we'll just go with Kubernetes.
I admire you for keeping up with this because my head is spinning just thinking about it.
Well, I lived this, right? You walked over the last 11, 12 years, right? I've walked just about every conference, right? KubeCon, right? ONS and all that, and you see this happening and you're living it, and you're watching the difference in terms of what's happening on the sort of software orchestration cloud side, and then you see the networking side, and you compare and contrast, and I think that was actually quite helpful. We had the controller wars for a little too long on the networking side, I think, and I think that hurt us all, actually. But yeah, I'm waiting for the Kubernetes moment where it falls forward. And there are some examples of projects in there that, like DPDK, right? The Data Plane Development Kit, which is an acceleration framework that's, I think, adopted by all. And I'm sure Arpit has a lot of information around that for people who
I think that came from Intel.
Originally, Intel and 6Win worked on it, actually. So there's a history of it. And people interested, this is okay. So partially self-interest advertising supports Linux Foundation. We work with Linux Foundation. We wrote a paper around the history of sort of DPDK and myths of DPDK and the history of how it came about and the origins and all that. And it's there. It was, that piece was, I think we shipped it a couple of years back, but it's actually still relevant. We still get downloads from it, multiple downloads every week, 3-4 years in. And the interesting thing is it's still accurate. So pretty happy with that outcome. But yeah, anyone interested in DPDK, there is a Linux Foundation sponsored paper that we did that's available. You can find it on dpdk.org. And yeah, you can read about that. But that is the one that I think that was nice. The conversions help, right? So sometimes that helps. And anyway, so the SDOs, the standard development organizations, the open source organizations are critical as stewards to drive this forward. And I think the open source orgs should cull and retire mature projects that are past prime, right? Just kill some of those and move along so that we can consolidate efforts, right? Because we don't want dilution of resources, right? We don't want these, ego battles. I mean, you want some of that, but I think that's the point of debate and conversation. But I think what I would like to see to drive things forward is cloud providers and carriers, the ones with clouds, pick one, drive it, select winners, and then drive it forward so that we can concentrate our resources, because there's not that many people who can do networking open source. It's a tricky thing. And for everyone to be working on, their own 1,000 projects is not ideal. 1 of 10 or 1 of 50, I think that helps us get momentums. But in the end of the day, what I tell our clients and enterprises and the carriers is, align with high momentum projects, right? Ecosystem support is important because at the end of the day, if you're trying to put it into production, you need someone willing to support it, right? So anyway, so that's pretty much it. And let me wrap up. And I think I'm maybe slightly over time, but hopefully I've done it in 20 minutes. And
thank you so much, Roy, for that tour de force. You've given us a lot to think about.
You are very, very welcome.
Okay, next up is my good friend Arpit Joshipura, who has been contributing to IEEE Communication Society events for almost 15 years now, since the startup Redback was acquired by Ericsson and various other companies. And we want to thank you for that, Arpit. And we're both lovers of classical Indian music, so I know him from that world as well. Arpit, the floor is yours.
Thank you, Alan, for the great introduction. And
richly deserved.
All right. And hope you can see the slides and everything's good. All right. So Roy, actually, fantastic presentation and excellent kind of alignment. The only thing I'll call out is I thought when you missed the TCI in the TCP/IP, you were deliberate because it would kind of fix itself through auto retransmission, right? But
the IP layer does not up it. If I put TCP would have fixed it.
It would have fixed it. That's
why I didn't fix it.
Okay, so what we're going to do is I'm going to build on what Roy has and some of the positives. I won't go into the history, because it's very accurate. But what I'll do is I'll walk you through where things are and how things are converging and getting into the deployment. Okay. Now, before I do that, I know a lot of you in IEEE have not really kind of participated in open source, let alone, Linux Foundation. So give me 2 minutes to sort of walk you through that. Again, I'm going to take 15 minutes or so to.
Well, that's very appropriate because IEEE has really been left behind in the whole open source movement.
That is correct. So I think the good news is, we have Ashutosh and I are kind of figuring out the best way to sort of amplify this. But Linux Foundation, just for those of you who don't know this, is well beyond Linux. So Linux is the most deployed OS, so we won't talk about that. But over the years, what we have done is we have hosted these projects in either areas of technology that are disruptive or domains or markets that need transformation. So for those of you who want to understand which industries have seen that open source transformation, I would recommend you to download a white paper called Software Defined Vertical Industries. It's on our website. Just do a Google search on it, you'll find it. But basically, it covers the 700 years old industries. So telecommunication, energy, automotive, things like that, film industries, right? That basically were proprietary. They were 100 years old. They were all heavily regulated. And then in the last 10 years, they moved from kind of proprietary and standards and regulated to fully open source. And you can see why. So download that white paper. It's a good reading also. Now, when you get to open source, the magic is very simple. We host projects, we as in Linux Foundation or any other foundations, which allows us to create a developer community. The developers globally, and it's a neutral home. So everybody from the world, irrespective of geopolitics, contribute on this. Okay, this is probably the only technology mission that has been excluded from the global issues we are all facing. Okay, so everybody contributes on these projects. The developer community, and we as LF do the DevOps, CI/CD, program management, marketing, etc., leadership, right? And support these developers so that projects mature, they come out with releases, they go into products, they get deployed, and then the cycle repeats itself. Okay, so this is a very simple slide, but all the projects that you see on the previous slide, and there's about 800 of those in different verticals, and there is value to, there's two philosophies. There is the philosophy where there's a project for every use case or in every subsystem that you want to develop. And then there is a philosophy that says, hey, put out the best project, and over time, Darwin's theory will take on, right? So there's both philosophies. On the networking side, we try not to waste and duplicate effort. So we are trying to keep projects to minimum. Maybe there's one or two options, not too many, but that's kind of the philosophy. Now, the good news is these projects have a life cycle. Okay, so they are incubation, mature, deployed, and then for those of, as Roy said, for those that don't have a community, we archive them, right? And that is okay, perfectly fine. There's many projects that have been archived. Okay, so let's get to networking now. And let's get to a diagram that I think Alan sent out in the original email. But this is a sample project overview. If someone at the end of the day wants to build their entire stack using open source projects, this is how they could build it. Okay, starting from the left, we host projects in the ORAN Alliance software community, right? So all of the software that gets to be written for the ORAN Alliance is in the Linux Foundation. Then we get to the edge part of it, user edge, service provider edge. I'll talk about that in a bit. Whether it's you're coming in from mobile, residential, SMB, or enterprise, right? It doesn't matter. You come in, there's a whole bunch of public clouds. Then you have the NOSes, Sonic, Dent, we talked about that. And then there's the stack up, right? So, you could say, oh, there's so many projects. Yes, but each project has a focus, It has a community, it has a use case, right? So DPDK, Kubernetes, FDIO, right? The bottom of the data plane stack, if you may. And then disaggregation allowed us to do hardware and software separately and data plane and control plane separately. You get up the stack, you have now the controllers, right? And we are sort of zooming in on a couple of controllers, right? And part of it is, one is a P+V, the other one is an overlay. So you have Open Daylight, you have Tungsten Fabric, right? Similar to, VMware NSX or Cisco ACI, right? Like P+V or overlay. And most of these the deployers understand how to utilize this. It's over 8-9 years now that since these projects are running, they're deployed, nobody talks about it. Then you get into the orchestration management analytics, right? So that's where ONAP comes in. This came along because of AT&T and China Mobile coming together with 2 massive open source projects that allow for control loops and on all the standardization of APIs through OSS BSS, right? So this is one of the largest community. And then on top, you have newer projects, whether it's packet core, right? So things like Magma, things like SD Core, or you have an enterprise project like Leaf, which is like what Walmart's using for eBPF lifecycle management, or Kamara, which is a set of applications, application development that's coming up. So these are all in the application space, but you can see that everything started, in the SDN world at a very low data hardware, software, low level. And then over time, in the last 10 years, has moved both up the stack as well as across edge and access. Okay, so this is, and it has been done through not just open source software, but open interoperability, open APIs, and the best part, which I'm really proud of, is open collaboration. Now, 5 years ago, it was a competition, right? Is it standards or is it open source? And they were not together. Roy gave a great overview of that. And what we did was we, at the Linux Foundation, working with senior analysts, right, Roy and others, right, we were able to work with pretty much all the standard organization to sign an MOU with the Linux Foundation and make a very simple case. And that case is the following. If a standard exists, the community will code to that standard. If a standard does not exist, the community will code to the standard and upstream it back into the standards. And that the value for standards organizations, specifically ETSI or MEF, TMF, 3GPPs, you get a very quick feedback loop that the standard actually can be implemented efficiently, okay? Because just having APIs is not enough. There's a data model behind it and a lot of other, and it's only the code that will guarantee you that it works. So we have a whole bunch of, partnership there, not just with the standards, but also with the other open source organizations, right? Whether it's OpenStack or whether it's Eclipse or ONF or others. And then if you look at the edge is a very vertical specific market, right? So there is no one solution for edge. So we have gone in and established partnerships with alliances and consortiums, right? Whether it's ACC through for automobiles or Digital Twin Consortium or whatever, right? And so what has happened is this collaboration has really helped not just jumpstart the open source networking, but also jumpstart the open source edge movement. So let's get to the
Arpit, I think that collaboration is wonderful. I think you just need more publicity about it. I'm happy to write about it on the IEEE Tech blog.
Okay, well, let's follow up on that. Thank you very much. We'll do that. Absolutely a great suggestion.
That's a big, big positive.
All right, perfect. So then so that was networking. Now, if you zoom in on the edge, right, which is again, expansion of the networking system. 3 years ago, everybody was talking about, different terminologies, thin edge, thick edge, near edge, far edge, this edge, that edge, right? And what LF Edge as a sub-foundation within Linux Foundation did, the community, was they defined the terms, okay, in a Wikipedia style definition. So now the good news is there's only 2 types of edges that are not just relative terminology, right? There's a user edge, which is dedicated and operated by the user, and then there's a service provider edge, which is shared as a service. And edge compute is only relevant when applications need 20 milliseconds of latency or less, right? So if a sensor wakes up and dumps data in a cloud every week, it's an IoT application, it's not an edge compute application. So if you can download the state of the edge report, there's a lot of information and the definition and all that. But if you look at the implementation of user edge, you can either go and put it on a constrained device edge, so microcontroller, embedded compute, or you could put it on an IoT gateway or in a server room. And then across the last mile, you would put it under the base station or a smart central office. So the good news is edge compute is the next big thing that is going on. It is estimated to be 4 times the size of cloud computing. So very hot. And then we are hosting these kind of projects, which you see as the logos in different stages to enable use cases. Now, what are the use cases? There's about 20, 25 use cases you see here. Everything from cloud gaming to public cloud interface to buffers to predictive maintenance, et cetera, et cetera. I won't go through it. You will get all the slides. But point is, the open source world is taking a very focused deployment view, right? There is no more theoretical science projects going on. I'll be very clear on that, right? It's all about commercialization. It's all about deployment. It's all about moving the solutions forward, okay? The very, very theoretical, let's make this, is not something that is going on here, because that's what the community is pushing for, okay? Now, Roy brought out the enterprise challenges, right? From a networking perspective. What is happening is either the medium-sized enterprises are all running on cloud, and cloud is already open source. So indirectly, they're already open source. The large ones who have a data center, right? They're just getting like a package solution. But what they are seeing now is a huge vertical specific push, which is if you're in the manufacturing space or energy or commerce or automotive, these are the verticals that can take advantage of compute and data coming closer to you in 20 milliseconds, right? Whether it's a predictive maintenance or an energy use case or a retail use case. So what is happening is all these open source projects at the bottom are being consumed in enterprise by these use cases, right? Whether it's private networks, multi-cloud, visibility, and through the edge compute use cases on the top. They're already consumed by service providers, right? Cloud service providers and telecom service providers by default are open source based, right? So we're not going to, discuss too much on that. And then the next big end user, and you can call it the largest, is the government. And the government has basically made a call that we are building, and this is specifically true for US government, not just US government, but across the world. But US government is on the leading edge of making everything 5G and beyond deploy on open source, okay?
Wow.
And here is an example of what the US government presented at one of the conferences, specifically ONS, which is now rebranded at ONES, one Open Networking and Edge Summit, right? So Tejas Patel from DARPA presented this slide, and he basically said, hey, I'm going to put everything in open source, and I need Linux Foundation 5G Super Blueprint, which, by the way, not all projects belong to Linux Foundation. Just keep that in mind. But the blueprint concept allows integration and interoperability across these projects so that consumers like DARPA can use it, or USD-RNE, or there's many of these. And then they've also picked up a lot of research with their universities to contribute back into open source. So for example, USC is contributing secure network slicing back into ONET, right? As an example, right? Which Roy brought out. Like, how do you contribute back? You contribute back by putting your research back into the mainstream and not forking. So really good progress on the government side. The big focus for open source community is security. Okay, so everybody knows it's more secure, more eyes syndrome. There's research papers from Harvard, MIT that prove this mathematically. But how do you prove it with tools and platforms that you can actually see? So this is beyond vulnerabilities and CVEs that are being tracked. You can go now to LFX security. We have a platform tool that allows you to see security in each of these projects. And we have projects like OpenSSF that allow benchmarking of how secure you are, okay? All the way from CVEs to SBOMs, which is software built of materials. Where does the software come from? Whatever the package is, right? Very detailed view of how to provide open source security. So this is a challenge, but it is being solved community-wide across not just networking, but across all these projects. Okay, talking about growth, DPDK, 10 years, 6K% growth, right? On developers, it's kind of the oldest, one of the oldest projects, right? You can see LF networking, 100% growth there. So these are, you can get these stats right from the LFX Insight tool that we have. But point is, the community is growing, the developers are learning. It is the only portable skill that allows them to move across companies, okay? And so we offer a lot of training also for open source. But in general, there's tremendous growth on most of these open source projects. So to wrap up, if you are not already doing it, go to Linux Foundation, go to Linux Foundation Networking, get an LFID, start participating in any of these projects and project entities. And, there's a lot of interesting, cool things that you can do with the community as we move forward. So I am going to stop here. Hopefully I am.
Thanks, Arpit. I have one question for you.
Yes.
We talked about this before. The Linux Foundation networking seems to be in the lead of all the open source organizations, but there's also the ONF, the OCP, the TIP, and the ORAN. How does LF networking align with them?
Okay, so I can go into each one of them, or I can just give
Just give us an overview.
Okay, perfect. So in general, there's two sides of things, right? There's the alliances, standards, and kind of bodies that don't produce open source code, right? But they are a very important part of the ecosystem. So that is OCP, that is TIP, things like that. Now, what
the ONF produces open source code, don't they?
That is correct. So I'll talk about the code part in just a bit. Okay. So that's why in my slide I separated the two, right? The people that don't produce code and the people that produce code. Okay.
Right.
So the people that don't produce code, we have MOUs with them to allow for complementary interop testing as well as alignment of specifications. So, for example, Sonic is a NOS project I host, right? So we have all the software community in Linux Foundation, but the specification of the SI, which is which is the switch abstraction interface, is sitting in OCP, okay? And so we work very closely with them. We have 2 bi-weekly calls and making sure that the two go hand in hand, okay?
Excellent.
So their community knows how to work with us. Our community knows how to work with them. That's one example. If you talk about the alliances that produce code, whether it's OpenStack, whether it's ONF, right? Whether it's Eclipse, right? What we do there is, depending on the project, depending on the interoperability requirement for the use cases, we integrate them into the blueprints, okay? So they could be the 5G super blueprints or Crano blueprints or whatever. And the community will do an interop testing with that, right? Similar to, Kubernetes. Kubernetes is not, it is a Linux Foundation project, but it is not under networking, right? It is in the cloud infrastructure, right? So, but networking needs it because of, the cloud native direction. So we will just utilize it. We will have community meetings to facilitate what is called working groups or task force or SIGs, right? Between the two foundations, and then we'll move forward from that. So that's the high level answer to this.
Thank you very much, Arpit. Okay, next up is Ron Almach from DriveNets. DriveNets is arguably the most successful networking software company, and they evaluated the trade-offs between open source networking and proprietary software, or open source software and proprietary software, and chose the latter. And Ron is going to tell us why, perhaps enumerate the trade-offs that his company went through and where they stand now.
Mm-hmm.
Ron is from Israel. 10 hours time difference from here in California. We're on Pacific Daylight Time. So thank you for joining, Ron.
Thank you, Alan, for having me. Evening time around here. So the first thing that I wanted to review, and the intro from Alan kind of spared me from introducing myself or DriveNets, but we will get to it at the end. The difference between open source and open networking. There was a lot of talk, and the topic of this complete broadcast is about the difference, and is open source networking a thing, or is it something that is still kind of in the works, or maybe will continuously and always be under work and not really get into fruition. When I'm talking about open networking, and here I'm already introducing DriveNet into the picture, that's what we do. We're a software company. We have a solution which is a software stack, which includes an infrastructure layer, runs on white boxes. White boxes are not coming from us. We're not a hardware company by no means. And on top of this, we have a NOS, a network operating system, which we created. And it operates on these white boxes, makes them, behave like a standard IP router in an IP network. So from that perspective, we are open in the fact, or we are disaggregated in the fact that we are decoupling hardware from software. Anything to do with the interfaces between the hardware that we use and the software that we wrote is standard. It's defined via open APIs. So in that sense, yes, we are open networking, and no, we are not open source. Now, to kind of wrap our ideas around this, let's try to kind of understand what was the purpose of open sourcing, anything. So when talking about open source networking, I think the first, and I was there, I don't know, I wouldn't say 2011, but probably 2012 when I kind of chimed into this this game. Hyperscalers kind of started pursuing this, and the first goal or the first target that they had in mind is to gain control. Control over whatever is being inserted into the network, control over what features are going to be supported on which platforms, and what scale or what size of a platform is going to be implemented next. This kind of control was always in the hands of vendors and not the customers, the end customers themselves. Tying up to that, a vendor lock. Once you have a network which you started with some vendor, then in a way you're locked into using this vendor because management platform is already kind of there and it supports only equipment from this specific vendor and not others. So you're kind of bound to continue to use that same vendor. And to the most trivial idea of inserting a line card from vendor A into a chassis from vendor B, nobody even thinks about this. Like, we had this idea once, I don't know, 15 years ago. It was called ATCA. That idea collapsed itself. And then you had uniqueness. Customers, be it cloud providers or service providers, they need to have some level of uniqueness in their network in order to differentiate themselves from the competition. And they also need to have a platform which allows them to innovate towards future functions that they want to add into the network, be fast about doing these introductions of innovation. And I think the last item is TCO, the total cost of ownership. But I wouldn't say this is really the last item or the final item. I think this is all of it. When we talk about control, or when you talk about vendor lock or uniqueness or innovation, everything eventually boils down to how much am I paying to establish my network and how much am I gaining from having this network. So it all boils down to TCO. Now, when I'm looking at open source networking or open source period, we need to differentiate, again, two things. One is a component and the other is a product. And we saw numerous examples from what Arpit, I think over 100 items on that list from Linux Foundation, which is spectacular. And I think it's also a huge contributor and assists the industry tremendously. But in the sense that it establishes a sort of an infrastructure. I think some of the examples that were given also had an infrastructure, and then on top of this, you had applications which were using that open source and eventually built by companies who have revenue as their end goal, or what's on their minds. When you look into taking a component and building a product around it, that means that there is a company with a solid R&D Sometimes it's a startup with a solid R&D. Sometimes it's an integrator with a solid R&D, wraps around it and makes it into a product. And then that product becomes available. And that product, even though it uses open source, it's not, a free off-the-shelf product. You don't really see too many. I don't want to dive into specific examples because I do think that some examples do exist, but that's not the typical way to take open source and just grab it as is and call it a product. I would say the one example which I like to talk about because it's something that I did in my Mellanox days, something called SwitchDev, which is a driver for switch silicon that runs within Linux kernel, and you can just take native Linux and run it on a system, and it works, and it has routing and switching and everything. Really cool. We didn't have a lot of customers. Customers want something which is solid, want something which is fully supported, want something that there is one, I don't say one throat to choke, but one call, one number to call when you have any issues. One example or additional example which I can take is Sonic. And that's kind of classic open networking or open source networking. And Sonic, first off, was not built as an open source. It was built first as something which was supposed to be run within Microsoft, and then open to the wider community for all sorts of reasons, mostly commercial reasons. I wouldn't dive into it because it's not on the surface, but way below the surface. But there's always some commercial reasoning why to open source something that you wrote in hard labor. And then you should also consider that Sonic by itself, be it an open source, as Arpit mentioned earlier on, runs on Psi, which is another open source, and also includes FRR, which is another open source, each maintained in a different place in the industry. So when I have an issue and I have Sonic installed, who do I call? My Sonic support line, and then what? It continues to kind of circle down the ladder until it hits somebody who's actually in charge. So even though Sonic, and I just heard that in the OCP summit a couple of weeks ago in Prague, Sonic has 3,000 developers working on it. How many of these 3,000 developers are actually working on it full-time job? How many are fully dedicated to working on Sonic? How many are actually Sonic, and how many are on other subsidiary projects that kind of evolved from Sonic or evolved into Sonic? So it's not really a task force of 3,000 people, and how do I reach them anyway? So even though it's there and it's solid and it's running probably one of the largest data center in the world, it's still not something that I can take as an enterprise and just use it as is, because it's going to be missing something, and then I wouldn't say I'm dead in the water. It's still a solid network operating system, but it's not something that I can just use off the shelf as is without any concern or any worry. And I do want to have some vendor with commercial motivation to kind of cater for this as I'm taking it in. Now, I wouldn't say as opposed, but let's take the other angle of open networking. And in that sense, what DriveNet is doing is kind of working through open standards. TIP and OCP were already mentioned here a couple of times. The product that we developed was defined under OCP. It was defined by AT&T. AT&T made a contribution of this definition. It's called DDC, Distributed Disaggregated Chassis, and that was contributed into the telco group inside OCP. The definition is open. It works mainly on the architectural interconnect between all the different components of the solution. How does the management plane work? How does the data plane work? And how does it interface to the software? What are the basic demands from the software in really high level? And then eventually builds a router. But where is the feature set of that router? Where is that standard definition of what does the router supposed to do? That's not defined in OCP. This is actually defined under TIP. So TIP took this and as Arpit said earlier on, I wanted to jump in and say it myself, alliances align. That's what they do. So TIP kind of took the other side of this definition and took the software side of it and defined what's called DDBR, disaggregated, distributed, in this case, backbone router instead of a chassis. And that talks about the router functionality of the same infrastructure, right? And in a way, we implemented something which is aligned to both quite easily because they really align one with the other.
But you don't use open source code, right? You use your own code.
Correct. So it's open networking. We have an open API. We developed something which is defined as an open spec, but the actual implementation is something that we do internally, proprietary. This is our intellectual property, you could say. There is a lot of engineering put into this, and I would say our claim to fame is by how we made this DDC work as a unified single network entity or single router in the network. Eventually, like I said, it's working. It's something that we built, and it's proven as something which is available today. It is field proven. When we have a customer, one famous customer everybody knows about, it's AT&T. A huge deployment with AT&T. Over 50% of AT&T's core network is running on this DDC coming from us, which is quite spectacular. We also have other customers. It's not only AT&T. We have customers in India. We have customers in Japan, tier 1 customers in Europe as well. Also other than AT&T in the US. So we have other customers. We cannot name names still, unfortunately, but they are there.
Are they all telcos, or do you have any cloud customers?
Telcos.
Yeah, thanks.
Absolutely. Yeah, there are telcos, and the use cases are varying from core networking to peering networking and all the way down to edge networking. It's a network router, right? It's a network router and all kind of various use cases of how a router is expected to behave. So from that perspective, it's working, and it's also field proven. It's robust, it's 5 nines, it's carrier grade, all these nice terms. Obviously certified because we built it according to specs, right? OCP specs, TIP specs, so DDC and DDBR. So it's built according to specs, therefore certified. And then there's also an ecosystem, and in a way, it provides a strong base of something that is solid and working. It provides choice. For whoever is consuming this as a product. It provides something which I'm not too happy about, but it's there and it's good for the customer. It provides built-in competition. When a customer is taking a product from me, his ability to swap me out even after deployment and take the software out, replace it with a replacement software from a different vendor, it's there. I mean, it's there. You can just do that one sunny day, and that's it. I mean, it forces me to perform. It forces me to provide software which is solid.
That's really interesting. So it truly is an open network then, where you can swap out one vendor's software for another. So it's an open network, but with proprietary network operating system and proprietary routing software.
Exactly. So what we broke is the lock. There is no vendor lock. The interfaces are standard. The simple example I can give is you can take Sonic and run it on any hardware that you want. You can take my software and run it on a variety of hardware, which is also certified according to the DDC specs. And some vendors do exist. We have UFI Space, we have EdgeCore Acton, we have Delta, we have Celestica kind of chiming into this game. So there are multiple hardware options on top of which you can pick and choose. And to an even further extent, you can pick and choose what product to take from which vendor, and you can take the same product from multiple vendors and kind of create a dual source, which is real dual source, not just pretend or have two different sources for two different products and kind of install one on this side of the network and another on another side of the network. You can actually rip and replace in between vendors, and you can actually kind of tailor in another vendor into an existing deployment for all sorts of reasons, be it, I don't know, supply chain or price or whatever. So in that sense, yeah, to your question, Alan, it's absolutely an open networking kind of approach. Now, looking back or taking these topics back and looking into open source now, we were talking about gaining control. We were talking about opening a vendor lock. We're talking about uniqueness and innovation, and eventually TCO, which is kind of the wrap up of all of this. So when it comes to having control, obviously it's an open source, right? You can develop whatever you want within that open source, obviously contribute it back if you have the skill set. If you have the task force to develop into an open source, definitely you can take that and make contributions and apply your control over whatever feature set is being supported, implemented. If we look into vendor locking, so yeah, absolutely, it is unlocked. But as long as you have an ecosystem behind it, it's also it's what makes it practical. Because an open source, even if it's open source, if it has no implementations of that open source available, let's say Sonic is an open source, but if no platform can mount Sonic on top of it, then it's useless. This is not the case. Obviously, plenty of platforms to run Sonic on. But just to kind of to make the point that a vendor lock is not freely granted by open source, but there needs to be an ecosystem. Uniqueness might be a bit of a challenge with open source, because once you take an open source, there's usually an aspect of licensing, be it GPL or other. So when you add into this, it's kind of not allowed to make this into commercial use, and if so, then you need to contribute back. So in a way that kind of takes out the uniqueness. It does allow you to innovate, right? You can innovate however you want into an open source, but if you want this innovation to be differentiating between you and the competition, then it's an open source. Right? There's no secret in an open source. So I'd say it's there. It's there in a sense that it is all enabled, but there is a price. And even though the open source is to begin with free, there is some effort into using it, and there is also some overhead when you kind of make this contribution back into the industry. Now, rolling back to open source and all of these beautiful projects that Arpit mentioned earlier on, or the set of flowers that Roy was talking about, it takes a village to develop all this beautiful garden of flowers, and there needs to be a reason. I grow flowers, I grow orchids, and it's a hobby of mine, right? I don't charge for it. But that's just me, right? In most cases, all of these companies that are contributing to these open sources, they have a reason. They are commercial companies. Their sole purpose of existence is revenue. It's not humanism. It's not altruism. It's to create revenue. And there's always a good reason for contributing into an open source. And it boils down to revenue, be it, by generating market share or setting the mindsets of people, or getting talent into the company, or getting market attention from a marketing perspective, or I'd even say eliminating competition, right? If I'm open sourcing something which a small startup is developing and trying to kind of nibble my market via, this way I can, just throw them out of the water by open sourcing something that they are doing. Good reasons, but eventually they all boil down to the revenue of some company. So attaching open source to a TCO, total cost of ownership, is, I'd say, too simplistic. It does reduce TCO, but there is more to it. There has to be a very robust ecosystem behind this open source in order to make it worthwhile. And there also needs to be a very strong core team behind this open source. I think the simplest or classic example is Linux. Everybody likes to use. There's a very strong team, a very strong core team inside Linux or around Linux. And in a way, that's the glue that kind of makes Linux into a thriving community or a thriving ecosystem. Now, I was talking TCO, and I'm gonna get to close my item in a couple of sentences. I think the topic should not be named TCO, the cost of ownership, but the price of ownership. I would say TPO. And in a way, this is exactly what disaggregation solves. Open networking, somewhat like what Ravnitz has done and other companies have done as well. It allows multi-vendor. You can select hardware and software. You can select and be mistaken about your selection and then also replace. You are allowed to innovate within your platform, within your solution, within or via open APIs. When I'm talking about our implementation, we have an open API, not just towards the hardware, but also from our network operating system as a northbound interface API towards enabling access to the hardware or to the infrastructure to other applications, other use cases. So as I mentioned at the beginning, we have our software is actually two parts. One is an infrastructure layer and another is the network operating system, the NOS. The NOS is an application. We can also mount other applications. We can mount a firewall, or we can mount a DDoS prevention mechanism, or a load balancer, or whatnot. Network applications, obviously, because it exists in the network. And then we do not develop these applications. We enable them. We enable the API towards the hardware. So whatever, say, firewall needs to access the ASIC underneath, everything, then it has access. And that access is granted via our software layer, which again, it's open on its southbound and on its northbound, but it's not, again, open source. Scale, obviously, because we kind of broke open a chassis. Chassis is a lot of good things, but one bad thing, which is the actual chassis. It's a metal enclosure that in a way limits a lot of things. We took that away, so now we don't have any physical limitations, so we can build to whatever scale that we want. Competition is free to chime in. Anybody can implement EDC. It's there, the standards are there, the specifications are there, just need to put in the effort. Same for the hardware, obviously. So if I kind of try to wrap this around into a bottom line, is open source networking still a thing? I think it's always been a thing. Is it a product? I'm not sure. Does it need to be a product? I'm also not sure, because when I'm looking at the reasons why we have this, then I think all of these reasons are being fulfilled by existing solutions, alternative solutions, which are open but not open source. So in a way, I'm not really sure who is still waiting for this and why should they continue to wait.
Thank you very much, Ron, for that very refreshing, enlightening presentation. Now we're going to begin the panel session, and I've modified the first question based on the presentations that we've heard. We have learned from all three panelists that open networking is actually much more than open source software, that it includes open interfaces and open APIs and a bunch of other open things. The original conception of open networking, and in particular SDN, was that there would be a lot of open source networking software running on commodity hardware. And I don't see that happen yet. In particular, we don't see any commercial open source network software companies like a Red Hat, which Roy pointed out. So the question to the panel is, has open source networking software and open networking lived up to its potential and promise, or have they been commercial failures? Open debate for all panelists. Who wants to jump in first?
Roy, you want to start? I'll take it on next.
Yeah, I can. I mean, I think that the challenge is, what is the objective function, right, for open source and networking, right? What are we trying to optimize for, and what are the goals? And I think it's complicated because everyone has different goals. I think we just heard from Ron what their goals are for using open source in networking for their purposes, right? It's not to create an open source network stack that everyone can use freely, that you just pay DriveNet to support a fee for. But in the meantime, you can take it and use it on any DDC compliant hardware that you choose to. That is not their design, that's not their go. But to his discussion, the open architecture element of it certainly is working for him and his customers. Some of the components that I'm sure DriveNet is using in their software, plenty of open source, I'm sure, inside there, right? So I think from that perspective, there is potentially here commercial success with open source components, with open interfaces, with open architecture and open hardware, right? So I think that is the part that may be complicated. I think
It seems like open hardware has been more of a success than open software.
Well, again, it comes
Open
down
hardware
to
coming from the OCP, for example.
open hardware coming from the OCP, open standards and open blueprints coming from TIP, right? But at the same time, you could argue that if it runs using DPTK inside DriveNet software, right, or VPP from the FIDO, the FDIO project, right, that's successful too because he's using it, right? So I think, or if it's got Linux or stripped down Linux that's running inside DriveNet or BSD core, that's open source too. So I think, right, so I think that's why I think it's tricky. But I think to your point, Alan, if we were to say, hey, I don't have complete networking stacks, high-end router, high-end switch, which I have a highly robust piece of software that I can run reliably by buying any white box switch or router from any manufacturer, pick your favorite, right? Quanta, Delta, whatever, right? Yes, we don't have that. At the same time, I think to Ron's point is, well, there's a reason why we don't have that, because it's not clear that there's a easy commercial answer and that the open source itself is sufficiently robust, nor are incentives aligned with making those for commercial entity to make it super robust and sell it in that mode. I haven't seen that succeed. We've seen companies try to do that, right? I mean, if you look at the ecosystem, your EdgeCore, your Quanta and all that, your Pika 8 in the early days that was trying to drive open source and open, it's taken a long time. Now they're still around, and kudos to them for, and those folks over there are really smart folks, whom I respect a lot. It's hard to make that model work commercially.
I wrote about Pika 8 in 2016 on Ken Powell's website.
Yeah,
Glad to see they did succeed.
I mean, look, James Nell is still around. He's a smart
Okay,
guy.
what happened? But Roy, why aren't there commercial open source software companies? There was Cumulus Networks for a while. It was acquired by NVIDIA, but I don't know of any others.
That
I don't think they were open source.
Cumulus.
They were using open source. They were using FRR.
Yeah,
but
That's what I mean.
their network operating system was not open source.
Oh, right. Okay, right.
I think that the challenge I think we've seen is that commercially it's hard to make money that way. I think that's the fundamental, and I think that's what I've seen, right? And part of it too is a footprint problem and a specialization problem, which is that as I point out, right, you have a lot less servers and desktops and laptops, out there in the industry than there are switches and routers, number one. Number two, the skill set required to touch networking is relatively specialized, right? And because if something goes wrong in your router, it's really, really bad, generally speaking, right? Especially if it's a core router. And so when you have those incentives aligned that way, and you're working with the service providers and the carriers who ought to be paying good money for these kinds of critical critical scale products, I think that open everything, I think commercially is hard to make work, right? So I would argue open source components have succeeded, open architecture, open infrastructure, open standards and APIs have succeeded. The full open source, in networking as a commercial model, I think it's tricky because of market dynamics. And I don't see how that there's an easy solution out there unless a cloud service provider, out of the goodness of its own heart, decides to make it super robust, invest, whatever they need to invest to make it commercial grade, right? 5 nines, 6 nines, and then open source all that and say, here, have at it, because we will benefit if we have a lot of smart people work on it and we get the upstream results of that. It's not clear to me that any cloud service provider is doing that. In fact, what I've heard in the early days is that some of them paid the Quagga team members or the core members of Quagga to improve Quagga to be so close to commercial grade. Those contributions never made it out to the open, right? So unfortunately, I think that's where we are. Right?
Okay,
So-
let Arpit
Yeah,
have
so
a
let
crack
me-
at it, but let me tell you what I have learned from this panel session so far. It seems to me that open source networking has succeeded, but open source networking software has not. Arpit, do you have any success stories you can share with
Well,
us about open
okay.
networking software?
So let's define the intent of each of these. Okay, so I think we're overusing terms and complicating things. Okay,
Can you talk a little louder because I can hardly hear you?
really?
Yeah, do you have your volume up? I can hear everyone else fine.
Okay, how about now?
Better. Thank you.
Better. Okay. All right. So first of all, open networking was invented, created, driven to provide choice. Okay. And keep in mind, it was a choice at the hardware software level, very low level. Okay. Can I buy hardware from one vendor, software from another vendor? That was the intent. Okay. Open source software, right, as Roy said, is about components. It is about projects that you can quickly build on and off, okay, and allow for rapid innovation and rapid deployment, okay? It is not, there is no one company that's going to come and put all the pieces together, right? That one does not exist, right? But there are multiple companies that can actually develop these components and make it production ready so that they can be used in a live network. And I'll give you some examples in a bit, but see the difference. And the value, there's two values. The first value that an end user gets from that is interoperability and speed of innovation. Gone are the days when RFPs come out, okay? You respond, 6 months to POC, 9 months to fixing bugs, 3 years to deployment.
POC is proof of concept.
Proof of concept, yes. That doesn't happen anymore. How many RFPs have you heard about? Most of these discussions happen in the open community, right? These guys like, I need this. Like when you have AT&T and Verizon and China Mobile and Deutsche Telekom and Orange and all these guys sitting in a technical steering committee meeting of one of the projects that they want to solve a particular use case on, the vendors will jump in. Today, the largest contributors of open source projects in our community are the top 10 networking vendors. The Ericssons, the Nokias, the Samsungs, the Huaweis, the ZTEs, you know, Cisco's, Junipers, they contribute, right? Why do they contribute? They contribute because they want to make the projects solid, right? The projects deployable. For example, Open Daylight, fully, you know, Verizon's running Open Daylight, okay, in their network. AT&T is running all of the ONAP as e-com project, right? The FirstNet, for example, all of the disaster, that's all there. Deutsche Telekom.
How does Verizon use Open Daylight for what?
As a controller in their network, right? And there's use cases, or there's what is it called, case studies published.
There's a vestige of SDN that has survived.
Yeah. So the components. So don't take open source software as a product, because then you're competing with Driveness. You don't want to compete. There is big value in a vendor taking components, adding differentiation to that, adding interoperability to that.
So it's part of an ecosystem.
Yes, and that is what Ran said, right? It needs a community. It needs common. But keep in mind, the best thing is interoperability and testing, and you don't have to multiply things 10 times. You don't have to solve the same problems multiple times, right? That's the speed of innovation. So that's the difference, okay?
Yeah, but
I'll just wrap it up. From my perspective, you asked a question. Is open source or networking a commercial failure? So I'd say no. Because commercial companies are making great money out of it. So it's not a commercial failure. And the classic, yeah. What was that?
Perhaps turn off your microphone and turn it back on. Mute yourself and
Your voice is being garbled.
How about now?
No, still no good.
No, still, okay, let me. Else, how about now?
Better. Yes.
Yeah, well,
Fine.
I switched to a different mic.
Okay, good. Much
My
better.
point is, because you were asking about, is it a commercial failure? So it's not a commercial failure because lots of commercial companies are benefiting from open source. So it's not a commercial failure by definition. And if I want to take an example, here, that's us, you know. We are a successful company and we thrive on
Well,
open source.
wait a minute. Open networking clearly is not a commercial failure, but what about open source networking software?
It's an enabler. It's an enabler for a lot of commercial companies.
Exactly.
As Arpit just mentioned, top 10 contributors are the top 10 vendors as well,
Okay.
because
I
it
think-
helps
Excellent.
them gain revenue.
Yeah, I think the part, Alan, that I think you're pointing to, I think there was a promise in early SDN with its controller market, the controller marketplace,
exactly.
the SDN apps. That has not succeeded. HPE tried
At the bottom level.
That's
At
right.
the very
Didn't
low
happen.
level of software. But remember,
Uh,
now it is all the way up. It's all the edge access. It's the entire end-to-end stack.
Yeah, what Arpit is pointing out is that we've learned that maybe verticalization or a more complete solution is the way to monetize it. Because if you look at the controller side of the equation, there's been no monetization. Lumina networks, that was a pure play, right? Running on top of Open Daylight. Lumina couldn't make it even with a lot of support contracts from tier 1 carriers, right? And Andrew Coward would tell you in all the scars, right? and it's not that open isn't important. It's not that open source isn't important. But I think what we're realizing is that the market structure, the market demands, and market dynamics are such that certain models will succeed. Open source is at the heart of them. In fact, is critical to many of these. Everyone leverages open source because why not, right?
Sure.
But a pure open source model, the SDN controller marketplace element, I think that's been proven time and time again that commercially it's tricky. It's kind of like even with ONF and ONOS, right? The success came from integrating with other things like Ether, like or whatever it is, and you have ONOS in there with, you know, and because it's end use cases like private 5G, and even beyond private 5G, it would have the private 5G with industry 4.0, right? Manufacturing use case or whatever it is. As Arpit's pointing out, LF is moving down the direction because I think the monetization stack, you need the above to monetize the below, I think is what we're realizing. And if you just go pure below, at least for networking, it's a tricky place to be. And I think the one danger we could be in potentially is with the RIC and Open RAN. I see some of the elements very, very similarly in terms of a controller type architecture, and then it accepts an R apps and Open RAN. We don't want to repeat that. We want to take the lessons that we've learned in the past. Again, another control point, you know, critical control point in the 5G RAN with a lot of innovation potential, accepts R apps, you know, and then we talk about marketplaces. I think we want to be careful again. Monetization has to be more vertical. I think it's what we're learning.
For clarification, RIC, I believe, is the RAN interface controller from
RAN
ONF
intelligent
software.
controller. It's the RAN intelligent.
ONF, and the open hardware is from the ORAN Alliance.
No. So I think maybe the ORAN Alliance defines the standards, as Arpit rightly pointed out. It defines the standards in terms of an open RAN architecture that conforms to certain specific interfaces. Under that ORAN Alliance, ORAN architecture, there's the SMO, and then the RIC sits inside. The RAN intelligent controller is a piece that sits inside that, that gives you real-time control and near real-time control or non-real-time control for the 5G radio access network. And that's a new controller piece that looks very promising. There's a lot of hype around. Yeah.
Okay.
Yeah.
Let's drill down a little bit more when we talk about success versus commercial failure. We all know that the open networking movement started with SDN and ETSI NFV in 2011, 2012. What's left of those pieces today? Those original models did not succeed. What aspects of SDN and NFV are being used today?
Let me start.
How do they relate to open networking today?
So remember, in the first conference, and I think I keynoted that one as well, you know, I said, I didn't say, but like a lot of people said, as open networking equal SDN equal OpenFlow. Okay, that was kind of
which is which didn't happen.
That didn't happen, right? We all know that, right? Because
so what I'm asking is, what portions of SDN and NFV are still viable, commercially viable?
Correct. So the NFV and the ETSI ISGs, right, have evolved over the last years. with different specs, different SOLs, as we call it, standards and APIs, right? All of those APIs have been implemented in projects like ONAP or projects like OSM or projects that actually talk to the OSS BSS, open source projects, right? So over time, the NFV portion has already made it into software and deployed, right? That train is gone, right? That's on the top side of things. The bottom side of things, meaning facing network hardware, right? OpenFlow is there. Some of them have implemented. You see a lot of other mechanisms, right? Like overlays and VXLANs and things like that, right? Like that traditionally solve the problem in a very standard manner, right? So that has happened. Now, if you take what is going on, the entire virtualization and network function virtualization is now becoming cloud native. Now, there is the definition of cloud native on our website, cncf.io, right? Like, just make sure, it's not, there's a very specific definition of what constitutes cloud native and what does not, right? You can't just package, like, you can't market yourself as cloud native and say, I'm cloud native, right? Just because you put it in a container. That doesn't work. But my point is, as applications move to cloud native, they become from VNF, they become CNF, right? Cloud native network function. And I, along with the late Dan Kahn from CNCF, we launched this term cloud native network function at Mobile World Congress, I think in 2018, right? And it has become since then very popular. But the concept then is you move from VNFs to CNFs at the application level, okay? At the orchestration level, you move from very rigid hardware configurations and hardware orchestration to a light touch Kubernetes type, right? Instead of kind of P plus V and OpenStack based Kubernetes. So projects like Nefio come in, okay? So in the middle layer. And in the bottom layer, right, you abstract enough so that you continue the advantage of hardware, software, but not just hardware and software, but also the NOSes. So SI. SI becomes that plumbing engine. Okay, so you see how things have evolved over the last years from what was kind of what started off as a huge disruption, SDN, to SDN, NFV, to now where we are. Okay, so it's a long journey.
So you've clearly stated that NFV has evolved from premises-based to cloud native, but what about SDN? You said that Verizon's running Open Daylight, which is part of SDN.
So again, remember, if you say SDN is OpenFlow, then no. If you say, if you say,
I'm not sure what SDN is.
Oh, okay. So let's go back 7 years, right? So what SDN is, in my mind,
what it was in 2011 is not what it is now. What I'm trying to get at from you and the others is what is left of SDN now.
Okay, so what is SDN, and which everybody will agree is it's the separation of data plane and control plane. Okay, at the highest level.
Yes.
The control plane aspect has now become the SDN controller. And there are 4 projects total open source and another 4 or 5 proprietary solutions for controllers. There's about 8 or 10 offerings in the marketplace. Everybody chooses one or the other depending on what they want. Okay, so the control plane part of software, SDN software, is fine. It is evolved. It is in deployment, et cetera, right? The interface and the standards that, quote, were historically led by ONF and Stanford and some of the other places, right, which defined OpenFlow 1.3 and this.
Right.
Those are not.
Well, what is used today is the interface between the control plane and the data plane.
It's not proprietary or different options. I think the architecture for SDN has continued. If you look at most of the new modern solutions that are out there, in the WAN or data center, wherever it is an SDN architecture. The actual programmable language that comes, and part of why ODL, Open Daylight, was expanded with different southbound interfaces was to recognize the fact that there wasn't a unified API or programmable language for southbound elements.
Right.
And so I don't think we've converged around what the right API is. In fact, I don't think we will because of where things are.
Because of the use cases, right?
Yeah,
and now there is P4. So
Exactly.
you can have any level of interfaces into the forwarding plane, as we call it.
That's correct.
Right? And that is okay. That is why the controller can abstract these protocols. I'll give you an equivalent example on the edge side. Okay, an edge and an IoT device messages right to the gateway. The messaging protocol is dependent on the vertical industry and the device. There are 150 protocols. A sensor or a pump may have different messaging. You can't unify them, but you can abstract them in the framework, right? That's kind of where we are in SDN.
Yeah, I think that's the reality of SDN. I mean, the controller wise, I mean, Arpit's right. There's less. I mean, controllers exist. If you go look inside, you know, Cisco, Juniper, right, Huawei, whatever it is, right, there is a controller element in there. There is a separation of control plane and data plane, and DriveNet has separation of control plane and data plane as well.
Yeah.
I mean, right, but is it that open source controller that we you know that we would like to have one or two of those? No, probably not. It's the southbound API OpenFlow, almost certainly not. Right. So I think that's sort of where we sit today in terms of where SDN is, and NFV has evolved in the same way. And as you know, Arpit pointed out, it's now cloud native, you know, network functions. And Etsy itself, NFV, you know, V4 specifications, you know, accommodates containers, cloud and, you know, and sort of cloud native. I think the migration is there. Now, you know, do people care about Etsy NFV standards anymore? Number one, SDN is a marketing term, an architecture term, is not a standard specification that you can comply with and conform to say, I am SDN, you know, and you get stamped, right? There's no SDN version 4, no such thing. NFV Etsy, on the other hand, the architecture is still strict. And I think people are realizing that it's more loosey-goosey with 5G and SBA architecture, right? It's now it's more cloud microservices, a lot more open, more cloud native architecture, more cloud native. There is no strict standard, but even then, I would say some of the elements around the description for VNF, around some of the standards like SOL 3 and SOL 5, those standards do exist. Even hyperscalers will conform to some of those. So I think there are elements that we've carried forward that still exist.
Yeah. And I mean, if you want to go down to the specifics, right? So Etsy came up with a CNF data model, right? Then we have the open source has adopted the Etsy SOL 4 packages. Then the SOL 7 network service descriptors, that has been adopted. The SOL 3, which is the interface adapters for the orchestration. I won't go into all the details, but all of these collaborations, right?
Yeah.
To me, they don't get publicized. They shouldn't get publicized.
That's where I'm offering to help you.
I know, but here's
the voice
thing.
of IEEE with the technology block. It's the second most popular IEEE website next to Explore. Number 3, voted by.
Let's do it.
Number 3 technology website in the world. I'm happy to publish for you.
Yeah, I mean, the standards exist, right? People do comply. Even hyperscalers, right, actually comply because
they all do, right? But the thing is, it is a given now in this industry where, you know, you're not going to fragment, right? Like we are going to harmonize, right? In fact, I would even say, if you want to look at a white paper on standards and open source harmonization, it's on our website. Okay. It is a couple of 3 years, 4 years old, but it is very good. It's still valid.
Yeah, harmonization paper.
Download that.
Yeah, harmonization paper.
Just a comment, Alan, about your comment earlier that you don't know what SDN means anymore. There's another guy called Martin Casado who quoted the exact same sentence a few years back.
And he's one of the founders of SDN.
In fact,
he's the founder. He invented SDN. Yeah.
Okay.
So he was quoted saying, "I don't know what this means anymore." And I agree. It's there. It exists. OpenFlow is an example. P4 is an example. SAI is an example. All of these are examples of what SDN has evolved into, and there are implementations of it. It's just doesn't go by the terminology of SDN 1.0, 2.0, 3.0.
Okay, thank you very much, everybody. Thank you. I'd love to hear about this collaboration between standards organizations and open source.
Yeah, we'll take that, Alan.
Okay, run. Want to give you some airtime now. Probably this is going to be the last question.
Mm-hmm.
Your company, DriveNet's, has been incredible success in selling core router and edge router software over disaggregated hardware. I don't know of any other company that has succeeded, and I have read that both cloud service providers and telcos are quite hesitant in doing that, as they have used forever proprietary boxes, proprietary routers, proprietary network equipment. What
Correct.
trade-offs did DriveNets go through when evaluating use of open source versus proprietary software over the open interfaces and disaggregated hardware that you use today, white boxes and bare metal switches?
Okay. First off, thank you for the credits. When we started, our first implementation was more of an NFV in a way. Original implementation was a router running on x86 servers, cloud native, as it was not just, as Arpit said, we didn't just put a container on surrounding it, but it actually was containerized sub items running on multiple machines. And yeah, we are eligible to be called cloud native. And then we resulted with the conclusion that it just doesn't scale economically. To build a router with 500 ports would require 250 router servers, which doesn't really add up into something that you can put into an actual network. So obviously, when we built it, there was no such open source that we could use, that we could, assist ourselves. Even Kubernetes was something that we didn't have available, so we developed our own mechanisms to control all these devices. And when we migrated from servers to white boxes based on merchant silicon, then the same. We needed to kind of write or establish these tools. I would say that if open source tools at the time would have been in existence, most likely that we would have taken at least some of them, but it just wasn't there. So in that sense, we are not against open source. It's definitely something that we could have benefited from as a tool as we kind of evolve into it. I would even say further, at the time, if a PSI layer had existed on top of Broadcom's Jericho ASICs, we would have used PSI, but it wasn't there. So we're using SDK. Open source does help. Open source is there when it's available. It's helpful. Again, it always boils down. I repeat saying that it always boils down to a commercial motivation. And when the company kind of consuming this is building it into a product which they sell, then yes, it does make sense. It does work. It does allow a lot of small companies to make revenue. Open source, and perhaps going back to your previous question about how come software is not successful in open source and hardware is. Well, eventually, even when the hardware is open, you buy the hardware from the hardware vendor. So it's okay to open, but when you open your software, you don't sell anything anymore. So it commercially doesn't make a lot of sense to open source a software piece. Maybe a piece, yes, but not the whole thing. So from that perspective, open sourcing or consuming open source into commercializing of our products is not a bad thing. It's just that, at the time for us, it just wasn't there. So we needed to build, well, most of it from scratch.
I want to encourage audience members to put their questions or issues in the chat. I don't see any right now, so I'm going to have one more last questions for all three panelists. Much to my astonishment and chagrin, SD-WANs became a commercial success for enterprise networking without any standards or even an NNI to connect different proprietary SD-WANs. There's nothing open about SD-WANs. Yet Gartner forecasts that 70% of enterprises will have SD-WANs by 2026. And by 2025, 50% of new SD-WAN purchases will be part of a single vendor SASE offering. Is the popularity of SD-WANs and SASE the reason for the seeming lack of interest in open networking today? What do the panelists think about that?
So
Particularly, this is true of the enterprise segment and to a lesser extent, the telco segment.
Roy, take this on because I have no comments on.
Yeah. So the number one, I think it's a slightly orthogonal question. SD-WAN is an enterprise edge solution focused at enterprises.
I don't think it's orthogonal because I believe that you hear so much about SDN WANs and that blots out anything you might hear about open networking.
So it's number one, it's a catchy name is a misnomer. I fought it originally when it first came out, but I lost clearly because I thought SD-WAN should be software-defined SDN WAN, like the B4 network that Google had. I lost that one. So SD-WAN refers to the current generation of enterprise edge solutions, right? So edge routing, edge solutions, that's what it is. It's an enterprise product that enterprises buy, from a single vendor or the carrier that's offering it. There is no need for interoperability, generally speaking, because there is no NNI, because you're using it all within, and you usually standardize within a company, with a few exceptions. When you have an M&A situation, mergers and acquisition, you may need that. But generally speaking, when I'm talking to enterprises, there's little need to standardize sort of cross data plane SD-WAN. There is some there is some demand for northbound standardization in SD-WAN, and that's from a carrier perspective, because they want to offer multiple vendors and they would like to have one orchestration system that can automate multiple vendors SD-WAN, and that's the extent of it. But SD-WAN is just a nice, cool name that's SD for what the enterprise edge networking really is, right? And I think that, now SASE is a whole different thing. SASE is Gartner's way of creating a new kitchen sink to throw all enterprise edge security into one bucket, right, to recognize the convergence in that, in that market, while still keeping the explicit labels below, so that the vendors can still look relevant in that, as they migrate to where the converged platform really needs to be. And SD-WAN has been thrown in that same bucket under the giant SASE umbrella originally, that no vendor actually conformed to. And so Gartner created a definition that none of the clients actually conform to. Subsequently, they backed off and added a new SSE on the edge security side, so that the Magic Quadrant could be created. So that's in reality how that came about. But SD-WAN has very little to do with the SDN conversations we've had, to the open source conversation.
Well, I know that, but
it is very popular, and is very
as a telecommunications standards professional, built a career on telecom standard. It's disgusting to see that happen.
Well, it's marketing. Marketing's won. The same with SDN. Marketing won, because SDN stands for nothing. The marketers won. I think the best way to think about SDN is object-oriented programming. It's like, did SDN succeed? Well, did OOP succeed? Yeah, it did, right? But similar and small talk and the original, things that embodied OOP, right? Well, they disappeared, but OOP succeeded. Same way, SDN succeeded, but some of the original controllers and OpenFlow and all these things wouldn't carry it along. But the architecture came along.
I see. That's a key point. Everyone should know that the architecture did succeed, but the individual components of it and products didn't succeed.
Yeah, I don't use small.
Alan.
Yes.
Alan, I would play along with your analogy of SD-WAN took the thunder from SDN. SD-WAN provided a solution which does what it needed to do for less money, less expense. So it replaced in a way VPNs, right? And offered a solution which is far less expensive than a VPN. It was just good enough for most enterprises to be used. So this is why it was so widely adopted. And it went into enterprises. So would enterprises have more attention to allocate into open source had they not been, brain theft victims of SD-WAN? Maybe it's a thing. I don't know. Maybe it's a thing, but it's two separate things. But there is definitely a chance that attention span is an item.
Thank you for the corroboration and agreeing with me. Now we have a question from Enos from the audience. He asked the panelists to show the success of open source, pick a metric such as number of routers using open source and indicate what is the percentage. Create as many metrics as possible. Is there such a study?
You cannot do that.
I would doubt it. I would doubt there's such a study.
But what you can do and what we have done,
that's going to be proprietary.
Every router and every box will have some open source. So
a router could be using Linux operating.
Yeah, exactly. So I think what you can do is you can do a community study of participation and community. How big is the community? How global is the community? How diverse is the community? Right? Like, for example, on the open source networking projects, 60% of the subscribers as controlled by the operators themselves. So the China Mobile, China, so top 2 US, top 3 China, top 3 Europe, right? All are collaborating. So that's kind of how we measure it, not by this metrics, right? So I know we'll be out of time, so I'm just keeping answers short.
Okay.
I'll say one thing, Alan. Linux is open source. I think 90% of NOS is using Linux. So by all means, most routers in the world are using open source. I would even say more. Sonic is open source.
Yeah, but
Google is using Quagga.
I would venture there is no such a study because all that stuff of how much open source is used in any type of IT equipment is going to be proprietary to the vendor.
95%.
What? Right?
I would say 95% of all networking equipment have open source in there, right? Maybe even 99%, right? BSD and Linux, I guarantee you 95% of all the NOSes out there are BSD based or Linux based.
Sure. Okay, thanks, Roy. Okay, the final question from Ashutosh. He wants to ask the panelists, potential security issues, how may they be addressed within the open source community?
Let me answer that very quickly. I covered it in one slide. There are 5 other slides beyond that, so I can cover it. But as a general rule, the only thing that historically was happening was CVEs, right, which we all know, right, vulnerabilities. So open source has formal processes to scan for license issues and for CVEs, and then the community fixes that. So that is the mandatory requirement. There's a OpenSSF sub-foundation that has now published guidelines on how to do open source security. So if you have not seen that, go to OpenSSF as a sub-foundation and download the guidelines. And that is true for all networking and all open source projects, okay? Networking, being a fundamental connectivity layer, is the first to implement those guidelines. And those guidelines go all the way from CVE, all the way down to, as I said, SBOMs, software bill of material. Where is this package coming from? Where did this come from? Which version of this? You know, is that scanned properly, et cetera, et cetera. So extreme focus and laser sharp. There's a checklist of about 150 things to get 100% secure open source component check mark on the website. There's tools called lfxsecurity. Just do a search on lfx.security and you will get it. I know we're out of time, but
Arpit, I want to thank you, and I want to thank the 2 other panelists. I am so pleased and so satisfied. I don't know about the audience members, but I learned a tremendous amount